We're continuing to conduct a sensitivity analysis using our decision tree here and deciding whether or not it's worth it to to invest in this new product. So in this case, we're looking at if we have a new product, we invest in research and development, we market it, we could have a good economy or a bad economy. Based on this decision tree, we could just terminate the project before R&D. We could terminate the project after R&D, but before we do marketing. And then we're going to be highly dependent on what happens to the economy. In our previous videos, we looked at what happens if the price that we're estimating for this product at $35 is different than we think. How does that impact our decision? We also looked in a video about what if the quantity sold is different in these two outcomes here for the positive and negative. In this particular video, what we want to do is we want to play with the probabilities. So what if the probability of a good or a bad economy isn't the 40-60 split that we think? So to do this, if you are following along with us, we are at drstephpowers.github.io/BIA, and we're right here in terms of the optimization Python workbook. And when you go in here, you will need to open in Google Colab. So there's a little button that appears right here, open in Google Colab, log in, save a copy, and that way you can play with it. All right, so what we have done is we have created our decision tree in a previous video. We have also defined a function. Let me just scroll back here. We have defined a function for this particular decision tree that gives us the value of each path, and that does the probability for each path by taking from our table how much it costs us for each step in the process. So if we are at A1, we are deciding to do R&D, that's going to cost us $10,000, negative $10,000. Plus, if we're going to do marketing, that's going to cost us extra $5,000. And then we have our money here from the sale of the product in a good and a bad economy. And we look at the probability of those different paths by taking the probability of R&D times the probability of marketing times the probability of a good economy to get the probability of that entire path itself. So we've created this function here to allow us to look at the estimated monetary value of the whole thing, and that comes from multiplying the paths times the probability of each path and adding it all together. So in this particular scenario, we've already looked at sensitivity analysis for changing the quantity. We've done a sensitivity analysis for changing the price. In this particular scenario, let's look at changing, let's change price and the probability of the good and the bad economy. So we talked about in the previous video is that you could create a loop inside of a loop for the different prices and scenarios. Rather than writing it as a loop inside of a loop, what we're going to do is create a loop where we loop through two items, but it's not listed as for something and something and for something and something. You can write it a bit more concisely, but what it is it's a loop inside of a loop. All right, so we start by creating our empty list, which is what we're going to populate to build our table. Let's look at three prices this scenario. $10, $20, and $30 for our price. Let's keep the quantities at 3,500 and 1,400. And let's assume that the probability of a positive or good economy is not just 40%, as we've been looking at in the previous, but what if it has a range? It could be 10 or 20 or 30 or 40. So we've set our assumptions here, and we notice that we're going to range through different prices and different probabilities of positive economies. Now, we need to import from InterTools, we need to import product. And that's because if we're going to write this as the loop inside of the loop, but more concisely, what we're going to do is we're going to use this product here from Iterative Tools. Okay, so the way that we write the loop is for X and Y. And X is going to be tied to your prices, and Y is going to be tied to the probability of a positive economy. The activity list is the same. The probabilities, what we're putting here is that the probability of a good economy, we put our placeholder y here so that it can be any of these positive numbers. And then the negative is just going to be 1 minus that. So before it was a 40% chance of a positive economy, and the negative would then have been 60%. If it's a 10% chance of a positive economy, 1 minus 10%, there's a 90% chance that it's a poor economy. So the y's are placeholders for our probability of a positive economy. And then our values here, we have the prices changing. So we have quantity underscore high, that's set. And we are going to loop through the 3 different prices, 10, 20, and 30. And the quantity is low, that's set. We're going to loop through the 10, 20, and 30. So you can see here we're allowing it to change both the price and the probability of a positive economy in our calculation. Then the rest of this is the same as you've seen before. We're going to take this information, we're going to use Pandas to turn it into a data frame, a table. And that table, we're going to set the index as activity. And by doing that, so I just scroll up here, means that the table will look like this, which means that our function is going to call location A1 and pull its value, or it's going to call location A3 and pull its probability to do its calculations. So that's why we've formatted into this data frame so that we can pull information from the locations and easily see here what our different paths are in our function. All right, so let's go back to our code here. Let us run the loop. Remember, it's going to call the function. The function creates a number of things, and so we want to actually match those names with the names used in the function. So we'll have our 4 paths in terms of their probabilities and their values, and then the total estimated monetary value. So we'll create that, and then we'll put it into a table so it makes life easier to read. And then what we're going to do is output this table. So notice when we create this table, we have 2 columns now. We need to create a column that is the price and a column that's the probability of positive. So when we have it append to the empty list, we need to give it X and Y and then give us the results of the function. So what this does then is it runs the price 10, the probability 10% of positive, price 10, probability of 20%. And so the table gets longer as we add more scenarios, different combinations of price and probability that it's positive. So what you can see here is that if the price is 10, as long as the probability of positive is more than 30%, we're making money. Not a whole lot of money, 132 bucks. And then you can see when the price is higher, we're making more money. At $30 and a 40% probability of a positive, we're making $8,196. And that comes from the good economy actually making us $90,000. But the other scenarios, the poor economy is only making us 27. And then we're losing money if we quit before then. So the probabilities then are changing as we change that probability of positive. Okay, we can plot this information here. And what we'll use for this is we will create a dot plot. We are using plotly.express as px. And we'll do px.scatter, call it figure, tell it where to pull it from. So pull it from our EMV underscore com underscore table. The x is going to be the probability of positive. The y is going to be the estimated monetary value. And then the color is going to be the price. So when we're choosing here, we can choose whether the color is price or whether the probability positive is the color. So you can trade out these two depending on what is easier to see. And we're going to have a bigger marker size, make the dots bigger. The x-axis title will be positive economy probability. The y-axis title will be EMV, and the legend title we'll call price. And we'll create this here. So what we get is we get 3 dots. So when the positive economy probability is 10%, we can see the estimated monetary value of that. And that's based on these 3 different prices, right? We have a high price, a medium price, and a low price. And so we can see then, and you can change the color scheme since that yellow is a little hard to see, that you can see that when the probability of positive economy is the highest and the price is the highest, we make the most amount of money. And then you can see here the scenarios where we are making the least amount of money. So if we look at this and go across at 0, notice that when that price falls to $5, then we're really not making money regardless of the likelihood of that positive economy. So we really need that price to stay above $5 in order for this to be a profitable endeavor.